In this video, we are going to discuss about the expected value and variance. So before that, we need to know what is a random variable. The outcomes of an experiment are represented by a random variable if these outcomes are numerical or if real numbers can be assigned to them. That means if I am rolling a die, then the random variable represented by the set of all outcomes of the numbers 1, 2, 3, 4, 5, 6. If you toss two fair coins, then the possible results are HH, TH, HT and TT. So now what you do, you have to assign a random variable X such that this random variable X denotes the number of head obtained when tossing two fair coins. So that means the random variable capital X takes the value 0, 1 and 2. If I say 0, the meaning is the random variable X is nothing but selecting tail and tail. That means there is no head. So which means we assign 0 for this. If I say X takes the value 1, that means we have one head. That means either we can select from this option TH or we can select from this option HT. So that means here H equal to 1, here H equal to 1. That means I am obtaining one head. So we assign X equal to 1. If I say X equal to 2, the meaning is in both times the result will be a head. That means I am selecting this possible outcome H comma H. So when two fair coins are tossing at a time, the random variable X takes the value 0, 1 and 2 provided we define X as the number of heads obtained when tossing two coins. The random variable is also called as chance variable or stochastic variable. There are two kinds of random variables are available. One is called discrete random variable. The another one is called continuous random variable. In this particular PowerPoint, we are focusing only on discrete random variable. So what is discrete random variable? If a random variable takes only a finite or countable number of values, then we called the particular random variable as a discrete random variable. Using this discrete random variable, we are going to define a distribution function called probability distribution function. So how we allocate the values for the probability distribution function? So we form a table. In the first row, we define the random variable capital X, which takes the outcomes of a random experiment x1, x2 up to etc. xn. Then for every value of x, we are going to assign a probability value so that you can write in the second row. So let me write P of x. So that means if I am taking probability for this value, we say probability of capital X equal to x1. If I consider the second value x2, then we define the random variable as probability of capital X equal to x2 such that up to etc. The last value will be probability of capital X equal to capital Xn. Remember, whenever you write random variable, you should denote by the capital letter. The value of the random variable we denote by small letters. And very important, the probability distribution always satisfy two conditions. Condition number one, the probability of x is equal to xi is always greater than or equal to 0. And if you add all the probability value, for example, this value plus this value plus this value plus this value, the total value should be equal to 1. So the probability distribution should satisfy these two conditions. Let us see one example. We have given a probability distribution. We have to check whether this probability distribution is a valid one or not. So here in the first row, they denoted the random variable x takes the value 0, 1, 2. In the second row, the value of x equal to 0, then the probability is 0.4. If the value of x equal to 1, then the probability equal to 0.4. If the probability of 2 is equal to 0.2. So what is my first condition? My first condition is probability of x is equal to xi, that is all the value should be greater than or equal to 0. So see the first value here. What is P of 0? My P of 0 is 0.4. So this is greater than or equal to 0. My second value P of 1 is equal to 0.4. That is also greater than or equal to 0. My last value probability of 2 P of 2 is equal to 0.2. That is also greater than or equal to 0. So all these values satisfying my first condition. What is my second condition? If I am adding all the probability value, that is P of, first replace the random variable x equal to 0 plus replace x equal to 1. So P of 1 replace x equal to 2 will get P of 2. So what is P of 0? Probability of 0, this one, 0.4. Okay, if the random variable x equal to 1, then what is the corresponding probability? 0.4. If the random variable x takes the value 2, then the corresponding probability value will be 0.2. So if I am adding, it is equal to 1. So the second condition also true. So I say that the given probability distribution is a valid one. Let's move to the next question. Same idea here. So first you will check all the values, the probability values are greater than or equal to 0. So if you see the first value, this is greater than or equal to 0. It's a positive value. This also greater than or equal to 0. This also greater than or equal to 0. But see the next value. You have negative 0.1. Okay. So this is less than 0. So what is the thing? The first condition P of x, capital X is equal to xi greater than or equal to 0 failed. So if it is failed, we say that the given values do not form a probability distribution. Once the first condition failed, we no need to check the second condition. There itself we can say the given probability distribution is not a valid one. Okay, see the next question. A random variable x has the following probability distribution. We have to find the value of k, p of x less than 4, probability of 2 less than x less than 5. So since they say it is a probability distribution function, we assume that the first condition is true. So what is your first condition? All the probability value greater than or equal to 0. What is your second condition? Sum of all the probability value is equal to 1. So here what you do, you are going to add all this probability value and these values, and you say the total value equal to 1. So let me write all the probability value and I say equal to 1. If you add these values, you will get 39k equal to 1. So from this, if you divide both sides by 39, you will get k equal to 1 over 39. So first case is done. What is my second question? Probability of x less than 4. So what do you mean by x less than 4? That means you have to take all the values of the random variable capital X should be strictly less than 4. So here your first value start from 0. So 0 is less than 4, so take 0. Next value 1. 1 is also less than 4, take 1. Then 2, then 3. So 2 and 3. So do not take 4 because they say strictly less than 4. So that means what? We have to add P of 0, P of 1, P of 2 and P of 3. What is P of 0? What is P of 0? P of 0 is K. So here you write K plus P of 1. What is P of 1? 3K. So 3K. Then P of 2, 5K. P of 3, 7K. So 3K plus 5K plus 7K. So if you add all these things, you will get 16K. So just now we have calculated K equal to 1 by 39. So here we substitute K value. So 16 times 1 by 39, that is equal to 0.4103. Okay, let us move to the third option. What is the third option? We need to calculate probability of the random variable x takes the value 2 less than x less than 5. That means you do not take 2, you should not take 5. You have to take the remaining values between 2 to 5. So that means what? P of 3 plus P of 4. Only these two values, because 2 we should not take, 5 we should not take. So what is P of 3? 7K. Plus what is P of 4? 8K. So 8K plus 7K will give you 15K. What is K value? 1 by 39. So 15 times 1 by 39. If you simplify, you will get 0.3846. Let us see one more question. Same like previous one. First, you have to find k. So what do? You have to add all this probability value and set the value equal to 1. So you will get this one. So if you add the left hand side, you will get 10k power 2 plus 9k minus 1 equal to 0. Okay, so this is a quadratic equation. If you solve this quadratic equation, you will get two values. You can use calculator or you can use this formula, minus b plus or minus square root of b squared minus 4ac by 2a. Okay, so you will get two values, k equal to 0.1, k equal to minus 1. So since the second value is a negative 1, we no need to take this one. So we have to consider only k equal to 0.1. Okay, what is the next question? The next question, we need to find probability of x greater than or equal to 6. So what do you mean by x greater than or equal to 6? You have to start from 6 because they have given equal to. So p of 6, after 6 what we have? 7. So p of 7. So we need to add p of 6 plus p of 7. What is p of 6 value? 2k power 2. What is p of 7 value? 7k squared plus k. So if you add these two and if you replace k equal to 0.1, will give you this answer. Next one, probability of 0 less than x less than 3. So don't take 0, don't take 3. What is the remaining value? 1 and 2. For 1 we have k plus for 2 we have 2k. So 2k plus k will give you 3k. So that is 3 times of k value 0.1. So will give you 0.3. Okay, using this random variable concept, we are going to form the formula for expected value or mean value of a random variable capital X. So the expected random variable or mean value of capital X is denoted by E of X. The formula for E of X is summation xi p of xi. That is the random variable x value multiply its corresponding probability value and then we have to take the total. Let us see this example. A game involves rolling a fair 6-faced die. If you roll a 6, then you will get 10 OMR. You will win 10 OMR. So let us define x1 equal to 10. So what do you mean by 10? If I am rolling a 6, then I win this game by 10 OMR. So what is the probability of x1? So x1 means if I am rolling a 6, then I will get 10 OMR. So p of x equal to 1 by 6. Next one, if you roll a 4 or 5, you will win 2 OMR. So let us define x2 equal to 2. So p of x2 equal to either a 4 or 5. So to get a 4, the probability is 1 by 6. To get a number 5 in a die, the probability is 1 by 6. So if you add, it will give you 2 by 6. Last one, if you roll the number 1 or the number 2 or the number 3, you lose 5 OMR. So that means x3 equal to minus 5. Why I am writing minus 5? Because you lose 5 OMR. Okay. So when I will lose 5 OMR if I get 1 or 2 or 3. So what is the probability of getting 1? 1 by 6. Plus what is the probability of getting 2? 1 by 6. What is the probability of getting 3? 1 by 6. So in this case P of x3 is equal to 3 by 6. Okay. Now what is the question? Find the expected value of the winning. So what is E of x formula? Summation x into P of xi. So what is x1 value? 10 multiply what is the corresponding probability value? 1 by 6. Okay. Plus what is next x value? 2. What is the corresponding probability value? 2 by 6. And finally the last value. What is x3? Minus 5 multiplied 3 by 6, the corresponding probability. So if you simplify, you will get minus 0.17. So what is the conclusion? On an average, we lose about 17 OMR per game. Why we lose? Because we got a negative answer, minus 0.17. See you in the next video.